Okay, today we're going to talk about graphing functions in different ways. This is 2.2. So we're just going to do a little bit of notes and a couple examples. So the first example is graphing functions by plotting points. Sketch the graphs of the following functions and state the domain and range. So for this one, we just need to, I'm going to zoom in right here for A. F of x equals x squared, so we're just going to make a chart of x and f of x equals x squared. And since this one is x squared, so the importance is on the negative and the positive values, both of them, we need to pick some negative and some positive values to use. And if you remember an x squared graph, it should look something like this, but we need to show some negative values over here and some positive values over here. So we need to do both. So I'm going to start with -3, -2, -1, 0, 1, 2, 3. Then you just square those answers to get your answers over here. 9, they're all positive. 9, 4, 1, 0, 1, 4, 9. And then you can graph that pretty easily. I'm actually going to put this next to it right here. Okay, 1, 2, 3, 4, 5. Actually, that was silly of me to make negative values in the y, but it's okay. So the x value, so this point, this is a point right here, so -3, 9, so -3 up to 9, -2 up to 4, -1, 1, 0, 0, the same on this side, 1, 1, 2, 4, 3, 9. And I am going to label those points. -3, 9, -2, 4, this is -1, 1, make sure they mirror each other, and then make sure that your graph extends forever in each direction, because if you kept going into the negatives, it would keep going up, and if you kept going into the positives, the values would keep going up as well. So make sure you draw those arrows. So your domain and range is going to be, well, your domain, if you think about it, you can go all the way into the negatives for the x and all the way into the positives for x. So that means your domain is going to be all real numbers, so that's -infinity to infinity. Oh, I always struggle with the infinity sign. And then your range, your answers are always going to be 0 or positive, okay? So no matter where you go in the x direction, your answers are always going to go up in the positive direction. So my range is actually 0, including 0, and up to positive infinity, only positive answers. Okay, we can move on to the next one. G of x equals x to the third. So I'll do this over here. So we've got x, and we've got g of x equals x to the third. So this is B, even though I'm writing it under C. And we're just going to do some positive and some negative values. Let's see. They did a fraction in this one, so we're going to do a fraction. We did -2, -1, -1/2, and the same thing here, 0, 1/2, 1, and 2. The fraction's helpful to show you how close it gets to 0. I'll explain that in a second. So 1/2 -2 cubed becomes -8 because -2 times -2 gives you +4, but then times -2 again gives you -8. So a negative number cubed is going to be a negative answer. Same thing with 1, -1. -1/2 gives you -1/8. And then the positive versions of that with the positive. Okay, so we can plot this. Make sure your graph is neat. Okay, you can go ahead and plot those values and label them. So this is -2, -8 is right here. -1, -1. See how quickly it gets close to 0? And then -1/2, -1/8. So right here. And then 0, 0. 1/2, 1/8. 1, 1, 2, 8. So it jumps pretty quickly up here. So this is 2, 8. I'm just going to label a couple of these. This is 1, 1. This is -1, 1. Oh, -1, -1. Okay, so this kind of curves like this and then jumps up to this point up here. I'm actually going to do that in a different color. So you guys have seen an x cubed function before. And then it extends both ways because every time you go into the positives, further into the positives for the x, the value continues going up for y, and the same when you go into the negatives, okay? So our domain is the same. Our domain is any value you can plug into x cubed. So that's positive to negative infinity. And then the range actually also, think about the y value, you actually also go down forever. It keeps continuing into the negatives, and it can continue into the positives forever. So actually the range is also all real numbers. Okay. All right, last one is C. hx equals square root of x. The square root, remember we can only have positive values for the square root because if we put some negatives in here, like a -4, the answer wouldn't work. It'd be an I value, and we can't graph I values, so we can only plug in positive values. So we're going to do that. So the square root of 0 is 0. The square root of 1 is 1. The square root of 2 is square root of 2. Square root of 3. And the square root of 4 is 2. All right, so we're going to go graph this. You can find those you can find those decimals for square root of 2 and square root of 3 to graph those correctly. 2 square root of 2 is going to be some fraction in here. Square root of 3 is also some fraction below 2. So it's just going to be like a tiny little increase, and then the square root of 4 is 2. So it kind of goes like this forever. It continues up like that. Okay. So the domain for this, we know, is only positive values including 0, because negatives will give us a imaginary number, and the range is the same from 0 up to infinity. All right, quick definition of piecewise functions. It is a function defined by different formulas at different parts of its domain. So it's broken into sections. The graph consists of a function of the graph of such a function consists of separate pieces. Okay, so we did an example of this before. We're going to do one again. All right, so the last one we're going to do is graphing a piecewise defined function. So we're going to sketch the graph of this function and state the domain and range. So we're going to set up the XY chart just like the last ones. But a quick notice is that we have two different functions going on here. So we need to split it. We need to get some values for this function up here and some values for the second function, okay? So the first function is x squared. So we already graphed that above. It should look like this, but it actually only goes up. X can only be less than or equal to 1. So it's actually going to be all negative values, and it's going to stop at x equals 1. So that's what we're going to graph for that one. And the bottom one is 2x plus 1. That's a linear function. So it's going to be a line. So that's what our piecewise function is going to look like. So what we're going to do is we're going to take some values that are less than or equal to 1 for our x squared. So let's do that. Let's start with -3 like on the last one. And it includes 1. Okay, perfect. And then on the bottom, since 1 is the kind of switching point, we also have to do 1 down here. So, so these are our x squared function, and this is going to be our 2x plus 1 function. So we need to start with 1 here and then just go from there, because x needs to be greater than 1 for the second function. So 1, 2, 3, 4. And then just plug those in. So these values up here we're plugging into x squared, so that becomes 9, 4, 1, 0, 1. And then these values down here we're plugging into 2x plus 1. So that's 2, that's 3, that's 5, that's 7, and that's 9. Okay, so let's graph that. Actually, this is better. 1, 2. All right, we can go ahead and graph these values. And then we have to stop at 1 for this. Hold on a second. We have to stop at 1, 1 for this graph because it says it only goes up to 1. But we could go forever in the negative direction, so we need to include an arrow on that left side. But the right side needs to stop at x equals 1. Let's go ahead and graph our second set of values. 1, 3, so that's above it up here. But it's not included. So for the 2x plus 1, our domain is x is greater than 1, so it can't include that value at 1. But we need to plot it anyway, because we need to plot every value above 1. So we can show that that's an open circle, so it's not included. So that's 1, 3, and then 2, 5, 3, 7, 4, 9. And if my graph was perfectly straight, it would be a straight line. This is a linear function. Okay, and it goes on forever in the positive direction because x can be greater than 1 for that one. Okay, so our range, our domain is from negative infinity up to 1 and including 1, and then from 1 to infinity not including 1. And our range is any value between 0 and infinity. Because even though there's a gap right here, let me show you, even though there's a gap right here, there is a y value over here in that gap. So it's actually not excluded. So 0 to infinity. I'm sorry, it includes 0.